Hello and welcome to another video. In this video we're going to be working on least number of unique integers after k removals. And in the problem you're given an array of integers and an integer k, and you want to return the least number of unique integers after removing exactly k elements. So for this first example, you can remove a 5, but then you'd have 2 elements left, so you want to remove a 4 because then you would have only 5s. And in this example you can remove 3 elements, so it says you want to remove the 4, the 2, and one of the 1s or the 3s. So if you remove the 4, the 2, and then let's say you remove a 1, you'd have 2 elements left. So they basically kind of show you what you need to do in this example. Like let's say we have some counts of numbers, right? Let's say we have like 5 5s, 4 4s, 3 3s, 2 2s, and 1 1. And the k doesn't really matter. Like we are trying to basically minimize the number of unique integers we have, right? So what's cheaper to remove? Is it cheaper to remove a 1? Because if we remove a 1, we'll have 4 unique elements. Or we can remove 2 2s, then we'll have 4 unique elements, or 3 3s, then we'll have 4 unique elements, or 4 4s, or 5 5s. The cheapest thing to do is just remove all elements with smallest count, right? So that's basically the best thing you want to do is you just figure out like, okay, what element has the smallest count? And let's just remove that. And we can keep doing this until we run out of numbers to remove. So let's say k equals like 6. We'd say like, okay, well, we want to remove all the 1s because that's super cheap. That's one operation. Then we have 5 elements we can still remove. Then we can remove all the 2s. That's 2 operations. Then we have 3 left. And then we can remove the 3s. And then we'd have 0 left, and we would say we have 2 elements left. And that's the idea. And if let's say k wasn't 6, let's say k was like 7, we'd have 1 element left. But then the next cheapest thing to remove is a 4, and we have 4 of them. So it doesn't really matter if we can remove a 4 if we can't remove all of them. So we can just stop whenever an element has a count that is greater than k, right? We can't remove all of it. Because like, yeah, we can remove a 4, and then we'd have 3 4s, but we still have 2 unique elements. But that's the basic idea. All we really need, and we don't really care what elements these are, by the way. All we really need to care about is these counts. So we just get the count of every single element in ascending order. So let's say our count is like 3, 4, 5, 8, something, right? 9. And these are the counts of elements. We don't really care which one. We just know there's 5 counts, which means there's 5 unique elements in here. And then for whatever value of k we have, let's say k is like 10, we're just going to say, okay, let's remove the element with the smallest count first. We can do that. Decrement k. Let's remove the element with the smallest count again. Decrement k. So 7 minus 4 is 3. And now this count has too much, so we can just stop. And whenever we stop, we just have to figure out, like, let's say we're on some index. We just have to figure out how many elements are remaining in the array, and that's how many we can return. And if k is all of the elements, so if k actually equals like n or something, then we, like, if we are able to remove everything, then we would just, as a default, return 0. But that's basically all we need to do. Just get a count of every element, sorting increasing order, and then remove elements with the smallest count as long as we can, right? And we don't really care, like I said, if we can partially remove something. Like if we have 5 of some element, we don't really care that we can remove 3 of them, because even if we remove 3 of them, we'll have 2 left, and we still have 3 unique elements. And that's kind of the idea, so we can code that. And we can use some useful Python stuff here. So I'm actually going to make an array of counts of everything like this. So we can say counts equals, so you can use a sorted function, which takes an array and sorts it, and gives you a new array. So the array we want, and actually we're going to use a counter, and a counter will take in an array, and it will give you a dictionary of every single key in its count. So we can say counter array. This gives you a dictionary, and now we can just take the values from there. We don't really care about like what keys we have. All we really need to do is get the values from there, right? The count of each item, sort it, get our count array. Now we just loop through elements in our count array from increasing to, or from whatever we are to the end, until we can't remove all of one element. So we can say for I in range length counts, if count I is greater than or equal to k, then we are, actually it's going to be the other way. If this is less than or equal to k, that means we have enough elements we can remove, right? So if a count of some element is 5, we just check how many elements can we still remove. If we can remove 5, we will. If not, we'll just return whatever's left. So if this is the case, we can continue. I think actually the easiest way to do that would, instead of removing it, is we can write it the other way. So if this is greater, no, actually it has to be this way, yeah. So if this is the case, we're going to decrement the count from k. So we're going to say k minus equals count side, right? So if some element had a count of 5 and k is 7, we're just going to decrement k here. Otherwise, we can just figure out, like, let's say we're on some index. So let's say our count is like 1, 2, 3, 4, 5. And we're on this index here. We were able to remove all of this. Really, all we need to know is whatever index we're on, how many elements are there starting from this index to the end. And so let's say this is index 2. There's 3 elements left, and the array length is 5. So what we want to return is the length of the array minus the index we're on would give us how many elements are left. So if like this is index 1, it would be 5 minus 1, so we'd have 4 and so on. If this is 0, 5 minus 0, we'd have 5. If this is 3, 5 minus 3, we'd have 2. So this works out for everything. So we can just return here the length of count, right? The count of every single item that we have minus whatever index we're on to figure out how many items we have left. So this is just going to be this. Yeah, I believe that's correct. We'll see if we got it wrong, but I think it's fine. Otherwise, if we were able to get through this whole thing and get rid of everything, then we can just return. We can even check for that beforehand, but it doesn't really matter. So let's just return 0 as a default because we were able to get rid of everything. And let's see. And I do think if you're using Python, it's good to learn counter. It's good to learn the sorted function, how to sort arrays. Like these kinds of things are used all the time in Python, so definitely want to start using them. And another language, you can just make you can just like get your dictionary values and sort them. So, but in Python, it's a lot more convenient. And here we go. So we run it pretty fast. And yeah, let's actually check what our k value can be. So k can be array length. So we can say if k is array length, we just return 0. We can even do that. Length of array. So we could do this too to speed it up in that case. I don't know how much of a difference it'll make, but yeah. Okay. So we don't technically need this because it'll never get here, but we'll just have it as a default. So let's figure out our time and space. So what are we doing? So we are going through all of our items and we are getting their count. So that's O of n already. Right? Like just going through all of our items and getting their count is O of n. Then we are sorting the counts of all the items. And worst case scenario, your count is roughly n. So that is going to be n log n to sort. And then we are looping through all of our counts, which worst case scenario is roughly n as well. So that's just O of n. So this part is O of n. This sort is n log n, and making the counter is actually O of n. So the whole thing is n log n. Space is going to be O of n because, like I said, worst case scenario, your count is roughly the number of elements in the array. It's never going to be exactly that, but it's going to be the same order of magnitude as that can be. And yeah, I think that's going to be all for this one. So I think the last few problems were pretty easy. So we'll see how it goes in the future. But these like counts and these types of things, definitely pretty easy. I think this is like definitely on the easier side of a medium problem. It's pretty intuitive to figure out that you want to remove elements with the smallest count first. So yeah, if you guys have any questions about any of this, just let me know in the comments as always. And yeah, if you did like the video, please like it. And I'll see you in the next one. Thanks for watching.